Hi everyone, this video we are going to continue learning about polynomials and how to derive information about their zeros. So far we have seen that some zeros are simple or nice, like they are whole numbers or rationals, and we saw how to find them. And then some zeros are not, like in this example we end up with some simple zeros like -2 and 5, but the last two zeros come out of this quadratic equation, which is solved using the quadratic formula, and so it contains a bunch of square root terms. Now next rule that we are going to learn is called the Descartes rule of sign. Okay, what's the goal of this rule? Well, the goal of this rule is to count how many real roots there are and how many of those are possibly positive, how many of those are possibly negative. So here's what the rule says. Rule says a number of real positive roots is the number of sign change minus multiples of 2, right? So for if this comes out to be 4, then you can have 4 or 2 or 0. Similarly, the number of real negative zeros is the number of sign change in p of negative x. Yeah, so you replace x by negative x and then you count, and however many these are, it's either that many or reduced by multiples of 2. So again, if this comes out to be say 4, then it could be 4 or it could be 2 or it could be none at all. Now what does a sign change mean? It's actually very simple. All you're going to do is you literally look at this sign, right? So from plus to plus is no change, no change. There is one change, because it goes from plus to minus and then no change. So there is a total of one change. So that means there is one positive root. Okay. Now 1 minus 2 is -1, and you cannot have -1 number of things, or so the only possibility is that there is one positive root. Now for the negative root, you just replace x by negative x. And what you're going to remember here is when you replace x by negative x, if it's an even power, it remains the same. Like if it's positive, it remains positive, because negative to the power even it becomes positive. And if it's odd, then it switches. So this is going to be negative, negative, negative. Now the first one, if there is no sign in front, it's automatically a positive. So there is one change and then no more. So that means there is one negative root. So what we know from this is that this px has at least, or in fact it has exactly 2 real roots, and of that one is positive and the other is negative. Okay, by real roots we mean roots that are real numbers. Now there are complex numbers as well, so that's what is happening here. Because it's a degree 6, you could possibly have 6 roots. However, we find that only 2 of them are real, so consequently it means the remaining 4 are complex. And that's going to be in one of the later videos where we study how to find those complex roots. So the Descartes rule of sign tells us, basically gives us this information about how many real roots there are, and of those many real roots, how many are positive and how many are negative. Now by itself, it doesn't let you find the roots, but it does give some information. And eventually the goal is to build up enough tools so that a combination of these can be used to analyze any given polynomial function. The next important result is called the upper and lower bound theorem. It says if p is a polynomial with real coefficients, the first scenario is you take the polynomial and you divide it by x minus b, where b is positive, using synthetic division. And if the row that contains the quotient and remainder has no negative entry, then B is an upper bound. Okay, so let's see what that means. Let's say that's the polynomial and we divide by x minus 2. Now 2 is positive. Right, so what does the division look like? There is a cube term missing, so I replace that by 0. -3 to -5, 2, copy the 1, 2 times 1, 2, 0 plus 2, 2, 2 to 4, 1, 2, 4, 8, 3. Now these 5 numbers here, these are all non-negative. Okay, now non-negative means they could be 0, right? But essentially there is no negative ones there. So if that is the case, then 2 is an upper bound for the root. What does that mean? Or for the zeros? Upper bound means nothing greater than that. Okay, so what this tells us is that any real root of this polynomial px is less than 2. So that tells us a nice thing. It says that beyond 2, this polynomial never crosses the x-axis. Right? So that's the first one. If you do this division and it comes out to be all positive, then that's an upper bound. And the second part is just the pairing of it, meaning if you divide by x minus a and a is negative, right? So that means it's like an x plus 3. And the last row has alternating positive and negative, or alternating non-positive, non-negative, then it becomes a lower bound. So it's the same polynomial, and in the same polynomial, now I divide by x plus 3. So 0, -3 to -5, so that's -3 here. That's 1, -3, that's right. That is, so 0 minus 3 is -3, -3 times -3 is 9, that's a 6, -18, -16, 48, 43. So what is that? That's alternating. So all roots of px are greater than -3. So lower bound basically means there is nothing lower than it. It's a bound to the. So this tells me that the graph of this function between -3 and 2 is where all the crossing happens. Beyond that, there is no crossing. Okay, so what do the lower and upper bound mean? Lower bound means there is nothing less than it, and upper bound means there is nothing more than it. Another way to say that is everything is less than the upper bound and everything is greater than the lower bound. Okay, so basically it gives you a range where the roots can lie. Example, show all real zeros of this polynomial are greater than or equal to -4. So what is that? It means that this is we're trying to show that this is a lower bound. Okay, so let's go ahead, set up the synthetic division, making sure that there's all powers of x, so there's no 0 that I need to place here. -4 gives me 1, -4, 0, -4 times 0 is 0, which gives me 3, -12 is -5 is 20 is 15. Now, here is where you have to be careful that it doesn't say that it alternates between positive and negative. It's a non-positive and non-negative, which means I'm free to interpret 0. So I can call this non-negative I can call this non-positive because it's 0. I can call this non-negative, non-positive, and non-negative. So it alternates, therefore -4 is a lower bound. Since it is a lower bound, every root or every real 0 of this polynomial is going to be greater than or equal to it. So that's it for real roots. Now, as I mentioned before, we saw an example where we had a 6th power equation, but we only had 2 real roots. So what about the remaining 4? Or how many should there be? That we're going to deal with that in the next videos where we talk about complex roots. Okay, that's it for this video. Thank you.